Imagine floating in the quiet dark of space. There's no ground beneath your feet, no up or down, just a slow-turning canvas of stars above, below, and around you. The stars don't rush or chatter. They shimmer patiently, some brighter, some fainter, each a tiny island in a sea of silence. Now raise your eyes or your mind and wonder, does this go on forever? Is there a place where it ends? What is at the edge of the universe? This is not just a question for scientists or philosophers. It's a question that echoes softly in the back of the mind, the kind of thought that visits you late at night when everything else is still. You close your eyes and picture the stars, then the galaxies, and then what comes next? The idea of an edge is something we know well here on Earth. Lakes have shores, cities have borders. Even clouds, as shapeless as they seem, have outer limits. So it's only natural to imagine the universe having an edge too. A final wall, a fence, a place where the stars stop and beyond which there is nothing. But in space, nothing is never simple. You see, our universe is not like a room or a box. It's not floating inside a bigger container. Instead, space itself is the container, and it's growing. Since the Big Bang around 13.8 billion years ago, space has been expanding. It doesn't expand into anything. It simply stretches like rising dough or the surface of a balloon as it inflates. And that's where things get tricky. Because if space is expanding and everything inside it is moving apart, then what does edge really mean? Some might think of the edge as the outermost border, where galaxies thin out and stars flicker less frequently. But no telescope, no matter how sharp, has ever seen such a wall. In fact, no matter where you look in the sky, you'll find galaxies scattered in all directions. It seems there's no edge in sight. Others ask, could the edge be the start of everything? The place where the universe was born? But according to modern cosmology, there was no single spot where the Big Bang occurred. Instead, space and time themselves came into existence everywhere at once. The entire universe was smaller then, denser, hotter, but not centered in one place. So again, no edge there either. Perhaps then, the edge is not something physical, but something perceptual. Something tied to our ability to see, to measure, to understand. And in that sense, we do have an edge, the edge of the observable universe. This observable edge is not a wall or a border. It's a horizon, a limit on how far we can see, not because the universe stops there, but because light from beyond that point hasn't had time to reach us. Light, remember, moves at a fixed speed, just under 300,000 kilometers per second. That might sound unimaginably fast, but the universe is vast beyond imagination, and even light has to work within time. So what we see, the galaxies, the glow, the cosmic web of matter, is shaped by both distance and time. The further away something is, the older the light we receive. In fact, when we look at distant galaxies, we're seeing them as they were billions of years ago. The farther we look, the further back in time we go. It's a cosmic time machine. And at some distance, roughly 46 billion light-years in any direction, we reach that limit. Beyond that, the light simply hasn't arrived yet. It may still be traveling, or the space between us and that object may have stretched so much that the light will never make it. So is that the edge? In one sense, yes. It's the boundary of the observable universe, the part we can see, study, and wonder about directly. But it's not the edge of the whole universe, because beyond that horizon, space could very well continue. It might go on, curving or stretching endlessly. Or it might wrap back on itself like the surface of a sphere, creating a universe without edges at all. The truth is, no one knows for sure. That uncertainty can feel uncomfortable. But it can also be beautiful. Not knowing everything leaves room for curiosity, for humility, and for dreams. So tonight, as you listen and rest, imagine standing on the shore of that great cosmic ocean. Imagine looking out, not with fear, but with quiet awe. The universe may not have an edge like a page or a planet, but it invites you to explore, to wonder, and to feel how small, and yet how connected, you are to something immeasurably vast. And that's where we begin. When we talk about the edge of the universe, we quickly run into something curious. An invisible fence, one that doesn't block us physically, but defines the farthest we can possibly see. This isn't a barrier built from stone or stars. It's built from light and time. We call it the observable universe, and its limit is the furthest point from which light has had time to reach us since the universe began. Imagine standing in a quiet field on a clear night, eyes fixed on the sky. Even with no telescope, your vision reaches back millions of years. The light from some of the stars overhead began its journey long before you were born, before humans built cities or dreamed of flight. Some of it began traveling before Earth even formed, and yet here it is, reaching your eyes gently, whispering across time. But there's a limit to how far this starlight can travel, and it's not because our telescopes aren't strong enough. It's because the universe has a birthday. Roughly 13.8 billion years ago, the universe began. That's when time and space, matter and energy all came into being. Since nothing can move faster than light, and light has only had 13.8 billion years to travel, there's a maximum distance it could have possibly covered. That distance forms the edge of what we can observe. But here's where it gets even stranger. You might think that the radius of the observable universe should be 13.8 billion light years, right? After all, that's how long light has had to travel. But because space itself has been expanding all along, the objects that emitted that ancient light are now much farther away than when the light began its journey. In fact, the current radius of the observable universe is estimated to be around 46 billion light years in every direction. That's 92 billion light years across. It's important to note, this is not the size of the whole universe. It's just the portion we can access with our senses, instruments, and understanding. It's like being surrounded by thick fog on a mountaintop. You can only see as far as the fog allows, but you know the land stretches far beyond what your eyes can reach. So if there's a boundary to what we can observe, what lies beyond that? Other stars, galaxies, structures, or something different altogether? Most cosmologists believe that the universe continues beyond the observable region, and that it may even be infinite. That's not just poetic, it's a serious scientific possibility. The observable universe is shaped by the speed of light and the age of the cosmos, not by the physical size of everything that exists. Still, within this invisible fence, there's an astonishing amount to behold. Roughly 2 trillion galaxies are estimated to exist within our observable universe. Each one holds millions to billions of stars. Many of those stars likely have planets. Some of those planets may even cradle life. And the further we look, the younger these galaxies appear. We're not just looking across space. We're looking back in time. The observable universe is like a giant spherical bubble around us, and because light takes time to travel, the edges of that bubble aren't showing us what things look like now. They show us what things looked like billions of years ago. The edge is not just far away in space, it's far away in time. And here's something mind-bending. Every point in the universe has its own observable bubble. If you lived in a distant galaxy on the other side of the sky, you'd have a completely different view of the cosmos. Their bubble would stretch 46 billion light years in every direction from them. In a way, we all live at the center of our own observable universe. But that doesn't mean we're at the center of the universe. That's just that every observer sees their own horizon, shaped by the light that's had time to reach them. This idea changes the way we think about edges. There's no hard boundary, no great cosmic cliff where stars fall off into nothing. Instead, there's a smooth fade, a dimming of visibility, a reaching toward the ancient, the distant, and the unknowable. So when we talk about the edge, what we really mean is the limit of the observable. It's the farthest reach of our cosmic eyesight. Beyond it, the universe likely continues, quiet, vast, waiting. The observable universe is our bubble of perception, a moving frontier, and it gently reminds us that knowledge, like light, travels with time. As you drift further into tonight's journey, let that idea rest gently in your mind. We're wrapped in a soft horizon of starlight. It doesn't hold us in. It simply marks how far we've come.